All right, so this is our final lecturette on Straightedge and compass constructions, lecturette 4, and we're covering a couple basic, more advanced constructions. We're going to start with a basic technique that I'm going to show you here. We're back in GeoGebra. You'll notice I got rid of the grid lines just for this part, just to show you some basics. And yeah, all right, so let's do this. So what am I doing? I have an angle here, and I want to bisect this arbitrary angle. Given some random angle, I want to bisect it. How do I do it? Okay, what I'm going to do, and what do I mean by bisect? Bisect, I mean cut it exactly in half. So I'll show you they actually have like a angle bisector here in GeoGebra, and you'll notice what I've done is if I measure the angle here, I've cut this angle, which is 128 or something degrees, and I've cut it into two angles. That's wrong. That's still wrong. Maybe I don't know how to use GeoGebra's angle measurement tool. If you do 241 minus 128, you get what, 60-ish? So I think I divided it into halves. I'll let you verify that. I don't know why the angle thing isn't really working, but that's okay. All right, I'll show you how to do it mathematically. Okay, first things first. Go to your center and measure out the distance to the closest of your 2 points. Doesn't actually matter. You can pick whichever one you want, but further point, bigger circles, which is kind of harder to look at. So I'm going to do a smaller circle here. Mark the point of intersection between your circle and your angle. So I've done that. Then measure, we're going to draw two circles. So we're going to get our compass, draw a circle from that intersection point to your center, like that. And then a circle from your intersection point to your other point, like that. So your center point to the other point, like that. Find the intersection between those two circles, and be careful, because sometimes you'll notice you get these situations where, if you're zoomed out a bit, it looks kind of like it's the point where the three circles intersect, but they don't all intersect at the same point. So make sure you're careful about stuff like that. All right, so we've done that. Then just all we have left to do is to draw a line from this center, or from this point of intersection, into our red angle, and you'll notice that we've bisected that angle. And I will try and check it again here. So this is 100, and maybe need to move that so I can double check. 122. There you go. That makes more sense. And then if I undo those angles, I will do the same thing. Angle here to here. So we're expecting what, we're expecting 61 degrees, and yeah, it looks like it's 61 degrees. All right, there you go. Okay, cool. I'm going to go back a bunch. So that's how you bisect an angle. Trisecting an angle is actually one of the major problems in the field of Straightedge and compass constructions. Yeah. All right. So let's draw the last line here and make this a triangle. So now we have some arbitrary triangle. We're going to start working on another problem. This is sort of one of the two big problems I wanted to do this lecture. I want to inscribe a circle. What does it mean to inscribe a circle? So inscribing a circle means that I want to draw a circle somewhere inside of this circle so that it is the largest possible circle that can fit inside of the triangle. So I'm putting a circle somewhere in the triangle. It's got to be the largest possible circle that will fit entirely within the triangle. How do I do this? Now, this is something that you couldn't really do freehand, right? You could guess, but are you going to be right? How do you even know, right? We've shown that this is the mathematically best way to do it. First up, you're going to bisect two angles. So start off like this. We will mark the intersection like that. And then we will do the 2 circles. Oh, where am I? Compass. Circle there. Circle there. Intersect. We're just doing the exact same thing we literally just did. Maybe I shouldn't have got rid of it, but that's okay. We're done it already. So there we go. We've bisected one angle. Let's bisect this angle up here now. So we've already got 2 of our circles drawn. The last circle I'm going to draw at this intersection here. So we'll do that. We will get our compass out. We'll go boom, like that. And then boom. And then we'll find where, maybe I'll highlight them if I can. This circle and this circle intersect, which is over here. Intersect, boom. Draw our straight line from that intersection all the way out here. Boom. We've bisected 2 angles. Now, those lines that I drew to do the bisection, where they intersect, that is going to be the center of the incircle. So this is a little bit surprising, but it works out so that it is always going to be the center of the incircle. We call it what's the term for it? The in-center. Yeah, literally the in-center. Okay, so let's find the intersection here between those 2 lines. That's what we've got. Cool. Now, how do we actually draw that circle? So what radius do we give it? We've got the center, but what's the radius that we're going to give it? So you might think about this and you might come to the conclusion that we need to find, like, it's going to end up being tangent to the circle, or sorry, to the triangle. The circle is going to be just tangent, just barely touching at each side. And at each of those sides, it's actually going to make a right angle, a 90-degree angle. So let's do that. Let's go ahead and do a little construction here. So what I'm going to do circle with center. I'm just going to draw an arbitrary circle that cuts through this red line at 2 points. There's 1 point, there's the second point. Oh, intersect, there's the second point. Perfect. Then from those 2 points, I'm going to use my compass. I'm going to get the length of that and draw a circle. And I get the length of that and draw a circle. And where those 2 circles intersect, I'm going to put a point. And then I'm going to draw a line through them. Now what you'll notice is that this line here is going to divide this circle, it's going to intersect with this red line at a 90-degree angle. And I'll show you that. Perfect 90 degrees, right? Now, notice the original line that we had drawn to bisect the angle is not 90 degrees. So this one here, this is 104 degrees. It is not 90 degrees. So we've got our 90 degrees. Now what we're going to do is find the intersection point between that 90 degree and the red triangle, like that. And we are now done. All we have to do now is draw a circle with the center at that in-center and the radius at that intersection point where we did the perpendicular 90 degrees line. And there's our answer. And I'll maybe make it this circle a little bit bolder or a different color so that you can see it. But there's your answer. That is the incircle. We have inscribed a circle inside of this triangle. So hopefully that makes sense. It's kind of a cool little construction. I'm going to give you some other practice ones to work on like this. I'm going to put on my grid lines like this. I'll show axes, snap to grid. There we go. And I'm going to delete all of this. And now we're going to do our last geometric problem, which is constructing a pentagon, a regular pentagon. Okay. How do we do a regular pentagon? I'm going to draw my 2 points. I hope I did that right. Point. This doesn't really matter, but I'd like to have it at 0 and 1. So as per usual, start with 2 points. We'll label this one as O, as per usual. I'll label this one as A, as usual. Okay, now what do? First, we're going to grab our compass and, well, maybe first, what we should do is draw a line segment between O and A. Now we're going to bisect that line segment. So we're going to grab our compass, do our little bisection technique. So find these 2 intersections of the circle, grab line segment, draw the segment between the 2, and then find their intersection. That is our midpoint. Cool. Now what I'm going to do is from that midpoint, I'm going to take my compass and I'm going to draw another circle around, so from that midpoint to O, and then up, I guess. And I'm going to label some of these points. I'm going to label this point as, let's call it L. I'm going to label this point as N. And then I'm going to label this point in the middle, where these 2 intersect, the circle and the line. I'm going to label this point as, if I can figure out how to do that, label this point as M. Cool, so we've got 3 points. Next step, I'm going to bisect the segment from L to M. So I'm going to find a midpoint for that segment. Cool, let's do it. Maybe I labeled these wrong then, sort of prematurely, but that's okay. We're going to do our regular bisection method, which is drawing 2 circles, finding their intersections, yada yada. This. Intersect, boom, and boom. So we've got that intersection. We will draw the line segment like that. We've intersected. We will mark that intersection. Now that intersection is going to become the center of our pentagon. And OA is going to be our first side of the pentagon. So I'm going to maybe make this red, and we'll make it thicker like this. Cool. Okay, now what I'm going to do is I'm going to draw a big circle of radius. Well, maybe I should actually give this a proper name. Let's call this point here, I don't know, X. There you go, point X. That's our center of our circle, is point X. I'm going to draw a circle around, sort of centered at X, of radius X to O, which is the same as X to A. So this is our circle. Our pentagon is going to be fit exactly within this circle. Okay, now comes the last part, which is kind of the cool part, because it feels like we've done nothing, and then all of a sudden the answer just pops out. Measure the distance from O to A, make a mark, or draw the circle, find the intersection with your main circle, and maybe I'll give this main circle a different color, just to be cool. I'll make it blue. Cool. So find the intersection between what I did here, just to show it again. I found, did a circle centered at O of radius up to A. So A is the outside point. I did that, and then I find the intersection between that circle and the blue, and I've got a point. Then I draw a line segment from O to that point. Okay, there's our second side, right? All right, now we'll do it again. We will get our compass, do another circle, this time from that new point to O. You'll find something here, and we will, where am I? Intersect that circle with the blue. There's our next point. Draw the line, and I'll give it a nice color, like this. Red 10, perfect. And I think you can see how this is going to go. We'll do it one more time. Draw the circle like this. The point or spot where that intersects is right here. Point, boom, like that. There's our last point of our perfect pentagon. And I'll just draw the two lines. There you go. So we are done constructing our perfect pentagon. And it's only been 15 minutes. What am I going to talk about? Maybe I will just ramble for a little bit. So now that you've seen this is how we construct a pentagon, it was a little bit challenging. I hope you were able to see that. There was a lot of moving parts there, both that and the inscribing the circle, but I'm going to give you more practice problems to do than you could imagine. So, all right, cool. So, what do I want to talk about to end this? I kind of want to talk about a couple things that are in the book, if you want to go further, and some of the connections to fields. So, to start off, there's an idea in algebra, two sort of ideas. One is called an ideal, and the other is called a variety. These are different types of structures. So an ideal is a type of ring. Furthermore, a field is a type of ring. So it's sort of like almost feels like a field, a ring. And an ideal almost feels like a field. Like it feels like a variation on that, where like maybe those rules aren't exactly the same as what we covered, but it's the same kind of feel, where it's like you're taking a set with some laws of composition, and you're sort of working out you're like working out these axioms, making sure that a certain set fits with those axioms. So that's the idea of a ideal. A variety is sort of similar. It's another kind of structure, but a variety is the set of solutions to some polynomial or some polynomial system of equations. If you take in linear algebra, that should make more sense, the whole system thing, but you probably haven't taken linear algebra. You don't have to have taken this course, so that doesn't really matter. But a variety is the set of solutions to some polynomial, the solution set. So as an example, if we have the polynomial that is x squared plus y squared equals, or I should say minus r equals 0, this equation defines a circle, right? It defines some circle of radius, I guess, square root of r, right? So it defines some circle, and the set of solutions to that equation is just the circle. The circle is the set of solutions. So every point that's on that circle is a solution. That defines all of the solutions to that equation. So we would normally write, if this equation is maybe like, let's say that this is a polynomial p, if we call this p, then we would normally write something like, there's sort of a couple ways to write this, but maybe math cal of v of p. It works. There we go. So curly v of p. This is the set of solutions to p. In other words, the variety of p. This is all the solutions to that equation, p. So in this case, it's a circle. All right, so this is a way that we can translate between geometry and algebra, right? So we've been dealing with a lot of geometry and a lot of algebra, and they've kind of been disconnected, but this is how you connect them, is you use ideals, which is in ring theory, which I'm not going to go into, and you use varieties, which is sort of from algebraic geometry, which is sort of on this side of that we've just been doing of geometry. So it's using equations, but it's sort of connecting equations to shapes, right? And in this case, in this way, you could sort of imagine how we could define everything in this setup using just these equations, these polynomial equations, right? Which means that in a sense, we could define a how do you say, a pentagon, or an inscribed circle inside of a triangle, right? Whatever, we could define that using varieties, right? Using this sort of math language of varieties. Yeah. So that's probably about where I'm going to leave it. We're at 20 minutes. I do want to talk briefly about, I can't ever pronounce it, but Nullstellensatz. I'm going to double check this on Google while I'm here, because Nullstellensatz. That's what it is. It's a weird German word. Nullstellensatz. So Nullstellensatz is a way that you can relate ideals to varieties. So it's a way that you translate from the language of, so maybe a better way to describe this. The way that we're going is we're starting with geometric shapes, and you can translate that into equations using what we were just showing on there. You can translate that to equations. Then you can translate those equations into varieties, using this like V of P. And then you can translate those varieties into ideals, which are rings. Rings are kind of like fields, right? We've done a lot of math with fields. And so from there, you can do your math, right? You can use all these powerful tools from field theory that we were just working on, and apply it directly in here. And then you could translate your answer back into geometric shapes. This is the process to show how some of these sort of interesting questions, like can you square a cube? Can you, not square a cube, square a circle? Can you trisect an angle? Can you construct any arbitrary n-gon, right? These are the fundamental questions of straightedge and compass constructions, but the answer to them comes through really interesting math, and that interesting math can be used in other realms too, right? So this sort of stuff gets used really everywhere. So hopefully you enjoyed this course. I think we're roughly done. I don't think I have anything more interesting to talk about without boring you. But I hope you enjoyed this course. So going forward, what are your next steps? Make sure you finish all of the solution sets. You only need to submit one for each, right? Pick one problem from each solution set, submit them to me. And again, this is only if you want to get grades. So submit one of each. Submit a final. You have two options for that final, which are posted online. Your choice as to what you want to do, but you have to submit one of them. And that's it. If you've done those two things, then you're good. I'll probably release like a post-course survey just to get an idea of what you felt, what you thought about this, if this is something you'd like to see more of going forward, sort of more other courses and different topics. But I just want to see how you found this. It's a new format for me, so I hope you really enjoyed it. I enjoyed making these videos. And again, if you want to go further into detail on this, our textbook is really good. Round in the Ruler. It's a very good book. Strongly recommend that you take a look at it. It goes slow, so it doesn't really require a lot, but his language is just very verbose. So if you're reading it, read it carefully and try to read every single word, because they all mean something. Like he's trying to cram as much power for each word that he uses. Hopefully you can take a read through it. It is sort of dated too. I don't know if you take a read through it, it's sort of using older language. Some of like the nuances are a little bit, or some of the ways he phrases things are a little bit, you can tell it was written a while ago. He'll use something like, every man does this, and it's like, well, that's not really the kind of language we use these days. So take a read through it. Be methodical, be careful if you're doing that. Nice and slow, and yeah, hopefully that makes sense. Hopefully you enjoyed this series. Let me know if you have any questions, and we'll see you at some point. Good luck with your future studies, and keep in touch if you're, if you want to ask more questions about this or whatever. Make sure you keep in touch. Okay, ciao.